Well, hello geometers and seekers of truth. In this video, we are going to learn what an exterior angle is, and then we are going to prove proposition 116 in Euclid's Elements, which says something about exterior angles. So simply put, an exterior angle is an angle formed by extending one side of a polygon. So an angle, or the angle formed or constructed by extending one side of a polygon. Okay. So if I have a triangle like so, let's call this triangle A, B, C. Then if I take one of the sides, let's say AB here, and I extend it, then let's call this point here D, then this angle in here, that's the exterior angle. Okay. So in this example, angle CBD is an exterior angle of triangle ABC. Okay. There are other exterior angles that you can make, but that's one good example of it. Okay. So with that in mind, let us proceed and prove or demonstrate Euclid's 16th proposition here. Okay, and it says the following. It says something about the inequality of triangles. So in any triangle, if one of the sides is produced, which is extended, then the exterior angle is greater than either of the interior and opposite angles. So the words here, interior and opposite, it means non-adjacent. Oops, non-adjacent. Okay. So angle ABD right here, that's adjacent. We're not talking about that one. We're talking about this angle here and this angle down here. Okay. So in order to demonstrate this proof or this proposition, we have to show two things: that angle ADC is greater than angle BAD, and going one step, and another part, that ADC is bigger than ABD. Okay. I'm going to show one of them here in this video, one of the parts here in this video. I will leave it to you as an exercise to demonstrate the other part. All right, so this proof actually requires some construction, and so I'm gonna show you the work that's done in the picture here, and then we'll write it down. So the first thing we're gonna do here is add a point. Let's call it E. And this point E has a unique feature. It is the midpoint of AD. Okay, we know how to do that in the previous lesson. We know how to find the midpoint of things, of line segments. So I'm not going to rehash that. Okay, so first thing we're going to do is make the midpoint of AD and call it E, and then we're going to join B to E. And however long this line segment is, we are going to extend it just as far out here. So we'll call this point here F. Okay? So we're going to join B to the midpoint, and however long that is, we're going to extend it out here to F. And then we're going to join D to F. Okay? So I'm adding this extra picture, these extra triangles here, in order to help me demonstrate why this first statement here must be true, that ADC is greater than BAD. Okay, so let me write up these steps here. Okay, so let E be the midpoint of AD, and I'm also writing here that this is from proposition 10. Where we do know how to find the midpoint. It's not something that we're totally making up here. And then the second part, we're going to join B to E. So however wide this is from B to E, we're going to take it a step further and make E to F the same length. Okay. Now I'm going to make a few other statements here visually first, and then we'll write up the step. This angle here is congruent to this angle here because they are vertical angles. Okay. And because that is true, if you look at the two pictures, these two smaller triangles, the one on the left here and the one on the right, these two triangles are congruent to each other because they have two congruent sides and the included angle congruent. Okay? In other words, side angle side. All right? So again, we have these two angles that are AEB and DEF. They're congruent because they're vertical angles, and the two triangles are congruent by side angle side. Now, since they are congruent by side angle side, we can say that these two angles here, this one up here, angle BAE and angle FDE, okay, they are congruent as well since they are congruent triangles. Okay, so and angle BAE is congruent to angle FDE. Okay, they're corresponding parts of the same triangle. So, and don't forget what I'm trying to show here, right? I'm trying to show that and I should rename this. Instead of calling it BAE, I should call it BAD. I'm sorry, that'll be easier for us to tell. BAD. And instead of FDE, I'll call it FDA. Oh, no, I'll leave it as FDE. That's fine. Okay, so this angle up here, BAD, so B to A to D, and F to D to E. Okay, I'm only renaming the first angle BAD because it's part of what I'm trying to prove here. Okay, now if we're trying to show that the big angle here, the exterior ADC, is larger than angle BAD, so at this point we're almost done. If you look at the picture, angle ADC is in fact greater than FDE. Okay. Well, why is that true? Well, let me change colors here real quick. ADC is this blue one, right? This big one, ADC. And FDE is this red one with the two arcs in it. So this is a common notion, right? That the part is greater than the whole. Sorry, I said that wrong. The whole is greater than the part. This is common notion 5. Okay. The part that's blue is the whole, and that's greater than the little one, that's the part. But if you notice what is written here, the little angle here with two arcs is equal to the little angle here with two arcs. So the two red angles are equal to each other, and one of them is smaller than the blue angle, so the other is also smaller than the blue angle. Okay. So since ADC is greater than FDE, ADC must also be greater than BAD. Okay. And this too is one of Euclid's common notions. It's actually the first common notion that things which are equal to the same things are equal to each other, or things that are unequal to the same things are unequal to each other. Okay. So there you have it. Our proof is complete. We've stated this, that we wanted to show that ADC is greater than BAD, and that's exactly what we've shown here. And I said there's another part to do this. We have to show that this other angle down here is smaller than the exterior angle. But that will be one of the exercises you can follow, and it's similar to the process that we did here. As always, thank you for watching. Keep working hard, and have a wonderful day.